Okay, welcome back. This is session 3 of the LEAP test or LEAP practice test. We are going to wrap all of our LEAP questions up with this final video. All right, so we are starting with 26. Okay, let me get my patty paper so we can do this right. Okay, so we have triangle ABC on the XY coordinate. The triangle will, I don't even need patty paper. The triangle will be translated 2 units down and 3 units right to create triangle A prime, B prime, C prime. So each point is going to go 2 units down, 3 units right. So this will be B prime. 1, 2, 1, 2, 3. And then 1, 2, 1, 2, 3. And then we're going to connect our vertices. Okay. All right, and then we're just checking off what will be the same and what will not be the same. Okay, the coordinates of A prime are not the same as A. We can easily see that. The coordinates of C prime are not the same as C. The perimeter of A, B, C and A prime, B prime, C prime should be the same. The distance from A to B is the same as A prime to B prime because they all shifted the same amount. So all the distances are preserved. Okay, since the distances are preserved for the perimeter, it should also be preserved for the area. Angle B and angle B prime should be exactly the same. The slope of A prime, C prime, the slope will be the same as this slope. Okay, so the only things that will not be the same are the coordinates of A prime and C prime. All right, 27. Select all expressions that must be equivalent to cosine A. So cosine of A, well, that is cosine of X. So cosine of A is also cosine of X. Okay, which is not on here. We just want to make sure. Okay. So if I were to list this as a ratio, cosine of X or cosine of A is going to be BC. AC, because cosine, let's write this out. So TOA. Cosine is adjacent over hypotenuse. The adjacent side is AC. So AC over the hypotenuse AB. Okay? And if you remember from a previous video, cosine of A is going to be the same as sine of B, or sine of X. Sine of Y is the same as cosine of X. So let's just look at this. Let's look at sine of X. So that's going to be opposite over hypotenuse. That's going to be BC over AB, which is obviously not the same. So this is incorrect. Sine of Y is going to be the opposite, AC, over the hypotenuse AB. And these are all cosine and sine, so they're all going to be over the hypotenuse. So let's just look at what the top would be. So we've got sine of Y is AC over AB, so is cosine of X, so sine of Y would be equivalent. Okay, cosine of 90 minus Y. So let's look at X and Y. X plus Y. If we have a triangle, the triangle has to add up to 90 degrees. Well, 180 degrees. If it's a right triangle, this is 90 degrees, which leaves 90 degrees between X and Y. So X is equal to 90 minus Y. Y is equal to 90 minus X. So sine of Y and cosine of X are what we're looking for. Cosine of X is also the same as cosine of 90 minus Y. So let's look. D is cosine of 90 minus y. Now, E is not necessarily untrue because cosine of 90 minus x could be the same as cosine of x if x is 45. But we don't know that, so that's not necessarily true. All right, let's look. We are also looking for sine of y. Y is equal to 90 minus x, so instead of y, we could do sine of 90 minus x, which is g. Okay, so my available responses are B, D, and G. F is not necessarily true because of the same reason E was not true. Okay. All right, let's look at 28. 28 shows line R, points P and T on line R, and the point Q that's not on line R. We also have ray PQ. Okay, so here's line R, P and T are on that line. Here's Q, there's a ray through it. Okay, we are trying to construct a parallel line through Q. So a line that's parallel to R through Q. What would be the final step in this construction? So we have made an arc and an intersection, a congruent arc with a congruent intersection. So how do I make a parallel line? So draw a line through P and S. Okay, well if I draw this line, and I'm going to do this in pencil so I can't erase. That intersects line R, so it's obviously not parallel. Okay. B, a line through Q and S. Okay, that looks like it could be parallel. Now, I'm obviously not drawing this right. I'm kind of not being very careful, so it doesn't look great. But we want it to go through Q. This is the only, this one says through Q and S. Again, that's not great, but it also didn't intersect R. So A we know is incorrect. Okay, a line through T and S. Again, that's going to intersect R, so we know that's not parallel to R. A line through W and S. It intersects R. That would be parallel to PQ, but not through R. So that's not going to work. The only one that's going to work is B. So if I want a line that is parallel to R through point Q, it's got to go through Q and S. Okay, part B. Once the construction is complete, which of the reasons listed contribute to proving the validity of the construction? So basically it's why are these parallel? Okay, so A, when two lines are cut by a transversal and the corresponding angles are congruent, the lines are parallel. And that would make sense because these are parallel lines. This arc from this point to S is the same as from this point to W. So those would be two congruent arcs. So this one makes sense. B, when two lines are cut by a transversal and vertical angles are congruent. Well, vertical angle would be this angle and this angle. That has nothing to do with the second line. So that wouldn't tell me if two lines are parallel. Definition of a segment bisector. We didn't bisect any segments. Definition of an angle bisector. We didn't bisect any angles. So A is the only one that makes sense here. Okay. All right. Let's look at 29. Oh, 29 is one of my favorites. A computer monitor is 20 inches wide. So let's draw ourselves a computer monitor. And then we'll go here. Okay. All right, here's our computer monitor. It is 20 inches wide. We don't know how tall. Now the aspect ratio, which is the width of the screen to the height of the screen, is 16 by 9. So where that comes from is with cameras, the ratio of your camera is 16 inches by 9 inches, or maybe not inches, but the film is 16 by 9 of whatever the unit is. And hold on, here we go. Just sketching this out, and I'm being a little OCD because y'all know it's Miss Gallant. Can't not be OCD. So basically what you don't want is you don't want to film with a camera that's super tall or super wide, but then your TV screens are not the right size for it. So that's where that 16 by 9 ratio comes in. And so we try to keep all computer monitors and television screens close to that 16 by 9 ratio. Okay, so we want to know the length of the diagonal of the screen. So we want to know what the length, because that's how they sell TVs to you, is by the diagonal. So you can have two 70-inch TVs that look completely different, like, you know, width-wise, which is kind of nuts, but, you know, it happens. Okay, so this is a right angle. We don't know this side, and this is the side we're looking for. Now, over here, I'm going to do the same thing. I'm going to make a right angle. We also don't know this side. We can do one of two things. Or, well, okay, there are two things we have to do. We have to use a proportion or similar figures, and we have to use Pythagorean theorem. The order does not matter. You could use Pythagorean theorem and find this length and then do similar figures, or you can do similar figures to get this length and then do Pythagorean theorem. It's up to you. I would do, you know, either way is fine. I'm going to go ahead and do similar figures from here to here and here to here. So let's look. Our width is 16 to 20, so 16 over 20 equals, our height is 9 to, we'll use h for height, 9 to h. Now let's look. 9 and 16 are on the same line. 20 and h are on the same line, so we're good. We're going to cross multiply and divide. So 16 times h is 16h. 9 times 20 is 180. We're going to divide both sides by 16. And the height of this is 11.25. Okay. So now let's use Pythagorean theorem to get this side. Pythagorean theorem is a squared plus b squared equals c squared. Hopefully you guys know that by now because every quiz has had a Pythagorean theorem problem on it. All right, so we're going to do 11.25 squared plus 20 squared. That gives me 526.5625. We're going to take the square root of that. So we're going to hit second x squared. And, x squared. That gives me a square root bracket. And then instead of retyping, we're going to hit second and this negative button. And that pops the answer in. So second answer. And so this becomes 22.95. We want it to the nearest whole inch. So this is about 23 inches. So that is a 23-inch computer monitor. Okay. Number 30. Points X and Z are on a number line, and point Y partitions XZ into two parts so that the ratio of the length of XY to the length of YZ is 5 to 7. So here's X, here's Z, and Y is in here somewhere. So from x to y is 5 times the scale factor. From y to z is 7 times the scale factor. The ratio is 5 to 7. We don't know if that's like, we just know that so if we add that out of 12, this side would be 5/12, this side would be 7/12, and that would add to one whole. All right. So the coordinate of x is 1.3. The coordinate of y is 3.8. What is the coordinate of z? So we know that this length is 5 times the scale factor. The distance between these 2 points, let's subtract 3.8 and 1.3. The distance between these points is 2.5. So these are two equivalent pieces of this number line. So we're going to set those equal to each other. 2.5 equals 5x. We're going to divide both sides by 5 to get x by itself. X is equal to 1/2. 2.5 is half of 5. Then I'm going to come over here to 7 and plug in 0.5. Half of 7 is 3.5. So the distance between 1.3 and 3.8 is 2.5. The distance between 3.8 and z is 3.5. So we're going to add 3.5 to 3.8. And we get 7.3. Okay. Number 31, another trig problem. All right. So we go ahead and write SOHCAHTOA down so I don't forget. All right. Okay, so Mariella is standing on a building looking out of a window at a tree. The tree is 20 feet away from Mariella. The line of sight, so look, if she cranes her neck all the way up, 42 degrees, she sees the top of the tree. If she cranes it down 31 degrees, she sees the bottom of the tree. We want to know, what is the height of the tree? All right, so we have two right triangles. Boom, boom. Let's look at this top one first. So we have 42 degrees. We have 20 feet, and we are looking for this length. So if we look, 42 is the angle we have. It is adjacent to 20 and opposite the missing. Adjacent and opposite is tangent. So tangent of 42 degrees is equal to our opposite side, x, over our adjacent side, 20. Now to get x by itself, we're going to multiply both sides of our equation by 20. And so x is equal to 20 times tangent of 42. I'm going to put this here, 20 tan 42. Okay, then we have the bottom of our tree, and we're going to come back and put this in the calculator in a second. So same thing, our angle is 31. We are missing our opposite side. We have our hypotenuse, so we're going to use tangent again. So tangent of 31 is going to equal x over 20. X is going to equal 20 times tangent 31. And to get our total amount of the tree, we're going to add these two expressions. So 20 tan 42 plus 20 tan 31. And we want this in feet. I don't know. It doesn't say to round. We'll see. So let's go ahead. We're going to put the whole thing in the calculator. And we're going to be careful with our parentheses. So 20 tangent 42. Close the parentheses. Plus 20 tangent 31, close your parentheses, equals about 30.03, so about 30 feet, depending on how they want the answer. It did not say, so does it say circle your answer? We're going to circle our answer. All right. Easy peasy. 31. Let's move on to 32. Such a fun one. We have a cylindrical container, and we are filling a big old fish tank with a little bitty cup. So we want to know how many times we need to fill this cup up and dump in here to completely fill the fish tank. So if we have, if we fill it up and we only need a quarter of a cup left, we need to add one more cup to fill it up completely. Yes, it'll be more than we need, but that's what but we just want whole containers. Okay. All right, so we have our cylindrical container, we have our fish tank. So when we want to know how many of these will fill up how many of these, we're looking for volume. So let's find the volume of the fish tank first. It's a rectangular prism. So you should have your reference sheet. Any basic prism, volume is the area of the base times the height. So let's look at the base. Our base is a rectangle that is 24 by 12. So the area of the base is 24 times 12. Then times the height, which is another 24 inches. So the volume of the tank is 24 times 12 times 24, which is a lovely 6,912 cubic inches. Okay. Then we need to know what the volume of our cylinder is. And we're just going to call it the cup because I have very limited room here. Volume of the cup is a cylinder. Cylinder is pi r squared times height. All right, so pi times the radius. Now they give me a diameter of 6, which means the radius is half of that, 3. We're going to square it and then multiply it by our height, 8. 3 squared is 9. 9 times 8 is 72. So our volume is 72 pi inches cubed. We'll convert this to decimal later. We want to keep this as simplified as possible as we go through. So if I want to know how many of these will fit into this, I'm dividing. So we're going to do 6,912 divided by 72 pi. Okay, so just divide by 72, we get 96, then divide it by pi, we get 30.55. And we need, it wants to know the least number of full tanks. So if we take the least number of full cylindrical containers. So if we fill this up 31 times, it will fill this up completely. Now, here's a quick word to the wise, because what I'm going to see people do is 6,912 divided by 72 pi. And they're going to get 96 pi. They're going to get 96 times pi, which 301 of these cups, which is way too many. And that's not at all what we want to do. So if you're going to put this whole thing in the calculator, be sure to put, be sure to put 72 pi in parentheses, because this takes order of operations very literally. So we want to make sure we do it exactly, put it in such a way that it makes sense. If you need to do it step by step and do 72 pi as a decimal and then divide, you can do that as well. Whatever is going to make sure you get the right answer. All right, 33. Octagon PQRSTVWZ is a regular octagon. C is the center. What transformations will map it onto itself? Okay, so if we reflect over QV, so what I'm going to do, let me find my patty paper real quick. I know I didn't need it last time. I don't really need it this time. We can do it without it, but why? Okay. We're going to trace this as best we can. Now, this is printed, so there's a possibility that it didn't print perfectly. All right, so part A, reflect over QV. So here's C, Q, here's V. We're going to reflect over line QV. So when I reflect it, I want Q and V to be in the same place. And I didn't draw it perfectly, but it matches up. So A is fine. So QV goes through this line. Or QV is this line. If we reflect over it, P should reflect onto R, Z should reflect onto S, W should reflect onto T. Okay, let's look at RW. Again, it goes through the center, so let's see. Let's move. Oops. Here's Q and V in the center. Let's do R, and let's do W, and let's trace that. Okay. RW. R and W match back up. And again, it all looks like it's right back on top of itself. So B works. Now let's look at TZ. TZ does not go through the center. So we have Q, we have R. Here's TZ, T, and Z. We're going to reflect it over TZ. And that does not line back up on itself. So C, no. All right, then let's do some rotations. D, we want to rotate 45 degrees clockwise around point Z. All right, so around point Z, clockwise goes this way, and we want it to be about 45 degrees. So we're going to make a little cross. That would be 90. And so we want this, when we rotate it, we don't want it to be a straight up and down cross. So this would rotate like this. And obviously, that is not on TZ. I'm sorry, that is not on the, we rotated around, I'm sorry, I'm looking at the wrong thing. We rotated 45 degrees around Z. It's not back onto itself. Now, if I rotate around C, I should be able to rotate around myself depending on where we rotate it from. So again, I'm going to draw my little cross so I know where my 90s are. And we're going to rotate 135 degrees. So here is 90 degrees clockwise. And then another 45 puts me here. See how I've got my X still? There is a slanted X, 45 degrees. Each angle, I think, is 45 degrees. Or each internal angle is 45 degrees. So, E is okay. F, rotating 90 degrees counterclockwise. Okay, so here's R. We're going to rotate 90 degrees counter. And again, I didn't draw it perfectly, but it does line back up. So F is fine too. All right, so on 33, our answers are A, B, E, and F. All right, number 34. Cavalieri's principle, or Cavalieri, I don't know, I can't say it. I'm not Italian. Cavalieri's principle, there we go. Two cylinders, each with a height of 50 inches are shown. Which statements about cylinders P and S are true? So let's look at A. If x equals y, if the radii are congruent, cylinder P is greater than, the volume of cylinder P is greater than the volume of cylinder S. Well, Cavalari's principle tells me that just because this is slanted does not mean that the volume is any less. If the bases are equal and the heights are equal, it doesn't matter if it's slanted or straight up and down, the volume will be equal. So this is split into two different sections. A through C is about the volume, D through F is about cross sections. So volume of P is not going to be greater. Volume of P is equal to S because the cylinders are the same height. That should be correct. Cylinder P is less because S is slanted. No. So only one of these three is correct, and that's that Cavalari's principle tells us that because they have the same height and the same radius, their volume will be the same even if this is slanted. Okay, D. If x is less than y, so all of these we are assuming that the radius of this is smaller. So let's say the radius of this is 2 and the radius of this is 3. Then we're looking at the cross sections. So if this has a smaller radius, the area of the cross section is greater than this area. Well, let's think about it. The cross section of both of these is going to be a circle. If the radius of this circle is bigger or is smaller than this circle, then the cross section of this should be bigger than the cross section of this because the area is just the radius squared times pi. So the greater the radius, the greater the area. So cylinder P, if x is smaller, so it should not be greater. X is smaller, so it should not be equal. X is smaller, it should be less than. So B and F are your correct answers here. All right, a few minutes left. We've got question number 35, and then question 35 is our final question. So yay, almost done. And then you can go look at the construct a response if you haven't done that yet. If you have done that, then you are about done. Question 35, triangle ABC and DEF are right triangles. Triangle ABC is similar to DEF. So A to B is similar to D to E. So AB is similar to DE. Let's keep it consistent. BC is similar to EF. I should have done it this way. And AC is similar to DF. All right, so then it says which ratios are equal to sine of C. So here's sine of C. Remember, sine is opposite over hypotenuse. So sine of C is the opposite side, which is AB, over the hypotenuse, which is AC. Now, if these are similar, then their proportions are the same. So AB over AC should be equal to DE over DF. So sine of C is equal to AB over AC and DE over DF. The rest of these will not be the same. Okay, the rest of this is 36 through 39, which is all constructed response questions. So you guys, you're finished with your LEAP review. Thank you so much for tuning in and listening. You guys are going to do so great. And if you have any questions, you feel free to email me or contact me. You guys have a great evening. Study hard. You guys are going to do so amazing on the LEAP. Hope you have a great evening.